Good day to you, Charger fam. This is Mrs. Boyd coming at you today with symmetry. So let's talk about a couple things about symmetry. We kind of all know what it is, but we want to know more details. So first, we're going to talk about the order. Order is the number of times a figure can be rotated about its center to map onto the same image. So we have this rectangle right here, and I can flip it over. Ooh, how you like that? And get the same rectangle again. Mine is real close. Now shut it. I can do that. I start with one triangle and flip it over and get two triangles. That means my order is 2. The number of times I can rotate an order around. Now the magnitude, the degree found by 360 degrees divided by the order. So for this rectangle that we just saw above, that's 360 divided by 2. So the magnitude is 180. Okay, so far so good. Reflection. A 2D figure has line of symmetry if the figure can be reflected onto itself over a line called the line of symmetry. So I know that this rectangle has 2 lines of symmetry. One is right here that splits it down the center. I know I could take this part of the rectangle and fold it up and create, it'd be the same. The sides would all match up to mirror image. Another line of reflection is right down the center vertically. I know that I could take this part of the rectangle and fold it over here and create a mirror image on both sides. All right, so that means this rectangle has 2 lines of reflection. All right, so list all the capital letters of the alphabet that have rotational order. Pause here. Give me one letter of the alphabet that has rotational order. I can rotate it around its center and get the same letter. Ready, set, go. All right, there are 7 letters. I hope you listed one of these. H. I can rotate it around this spot right here and get the same letter upside down. Another one's I. N, obviously O because it's a circle. S, I rotate it around and get the same thing. X and Z, those are all the letters that have rotational order. Now, letters with lines of symmetry. Pause here. Give me 2 letters that have lines of symmetry. There are 2, 4, 6, 8, 10, 12, 16. Ready, set, go. All right, here they are. A has a line of symmetry. B, C, D, E. Those all have lines of symmetry. H, I, K has a line of symmetry. M, T, U, V, W, X, and Y all have lines of symmetry, or it would if I drew it like a real capital Y should be. All right, so those, I feel like the letters kind of help because they're things we use all the time, and you can see how they're symmetrical and have rotational order. Now, let's put this info to some shapes, some geometrical shapes, and find out some data about them. So first we've got the triangle. We want to know the order. Well, I think about this is an equilateral triangle. It looks like anyway. So all of the sides are the same distance and the same length. The angles are all the same. So I could take this top angle and rotate it down here and put it in this spot, and that's one order. I can take this spot and move it over here. That's order of 2. I can take this spot and take it back up to where it belongs, rotating the whole triangle around, and that's order 3. Magnitude, if you'll remember, we do 180. Oh, nope, just kidding. We do 360 divided by the order, and that gives us a magnitude of 120. Lines of reflection, we have one here, here, and here. So we have 3 lines of reflection. Let's do another one together. The square that we have, I can take this corner, turn the whole shape around to here. That's 1, order 2, order 3, order 4. Magnitude 360 divided by the order, and that means our magnitude's 90. Lines of reflection, 1, 2, 3, 4 lines of reflection. All right, pause here. Try the next one on your own. Okay, this is a rectangle just like we had on the front. So I know I can take this corner and flip it all the way around and put it here. I can't put it here because not all the sides are the same length. I got to turn this all the way around this way, and that's order 1. Bring it back to where it started, and that's order 2. And then my magnitude, 360, divided by the order will give me 180 for the magnitude. Lines of reflection, 1 there, 1 there. 2 lines of reflection. Pause here and do the next parallelogram. Well, this is a lot like the rectangle. I can take this top right corner and scoot it all the way around to the bottom right or bottom left. That's order 1. Back to where it started is order 2. We can tell from above that our magnitude's 180. And this one has, I can't see any lines of reflection. If I put a line here, that this line is not equivalent to that one. So that can't be a line of reflection. We can't do one this way because those are not mirror images on either side. I think that one's got none. This one has no lines of reflection. All right, Pentagon next. Pause here and try it on your own. All right, so for the order, all of the sides here are equidistant. So I can move it 1, 2, 3, 4, 5 around. I can find the magnitude and do 360 divided by 5 and get 72. Lines of reflection. I have 1 coming from every vertex. So there's 5 of them. All right, this one looks like a price tag. It's a different shaped pentagon. Try this one on your own. Okay, I can't take this vertex and scoot it anywhere and have it look like the same shape that I just turned around. So this one has an order of 0, no order. That means our magnitude, I don't want to call it 0, I want to call it none. Our magnitude, also none. Lines of symmetry, I can see 1, and it's this horizontal guy right there. 3 more. Try the next trapezoid on your own. All right, we can take this corner and take it nowhere to make this look like the same shape at all. They're going to look different every time. So this one again is none on the order, none on the magnitude. Lines of symmetry, I can find one vertical right down the middle. Okay, time for the star. Try it out. All right, the star is special because all of the vertexes, all the points, out points are all right across from endpoints on all of the points of the star. So that means I can take each point and rotate it around and get the exact same shape. Since this has 1, 2, 3, 4, 5 points, that means my order is 5. The magnitude will be 360 divided by 5, or 72. Lines of symmetry, there's going to be 1 at every point of the star. Whoopsie, that one's not right. So 5. Last one, try it on your own. All right, we've got this plus sign. I can take this whole side and flip and turn this around until it's right here, because all 4 of these sides are the same. I can turn it around every time and have it be identical. So 4 sides, order is 4. To find the magnitude, we do 360 divided by 4 and get 90. Lines of symmetry, there's a lot here. So we've got 1, 2, we can do 3, 4. We can do 5, 6, 7, 8. 8 lines of symmetry. That's a lot. Okay, guys, I hope this makes sense to you. I hope you're following along real nicely. Let me know if you have any trouble, and I'll talk to you soon.